Welcome back to our channel. In today's video we are going to see part 4 of the 5 series for Tetris game development using JavaScript. Please have a look on previous part of this series if you have not seen it before for better continuity. You can watch step by step of this game development. Feel free to pause the video to re-look on any lines of code. Hope you will enjoy to play the Tetris game developed by yourself. Before going to the video, please subscribe and click like button if not already subscribed. We could place the Tetris block in its position. This is achieved by calling get Tetris next block after placing a Tetris. Now, instead of always giving I Tetris block, let us make a sequence such a way that at random order we will get the blocks. So we have already designed 7 Tetris blocks I, J, O, L, S, Z, T. 7 Tetris elements we have designed and it is stored in the array called Tetris block. I am just giving the same elements I, J, O, S, T, Z in the sequence array. Let me randomly pick one of these things. For that I will use math.random multiplied by 7 so that it is between 0 and 7. The random number generated shall be between 0 and 7. And using splice we will take the first element of sequence array. Once again I am reading it. Inside the get Tetris next block we are using the random method math.random and multiplied by 7 to get the Tetris blocks in random. First we got the I block, now we are getting the T block in red color. The coming one is S block. So the next one is O block, which is square. So we could successfully get the Tetris block in random order and ranging from I, J, O, L, S, T, Z. And the next one that we have to do is, so far we have not added any user control. So we will add the key listener. So it will listen if any key is pressed. So I will call document.addEventListener and then pass the parameter key down and a function of E. I am giving key down as a parameter because on pressing the key the event has to be detected and this function should be executed. Function of E, first one we will check if the game over variable is already set, because if we are already in the game over we don't have to act for the key process. Otherwise we will check if E dot which is equal to 37. 37 is equivalent to the left arrow. When a left arrow is pressed, that is key down, we want to move the Tetris to the left column. So before moving it, we will take a copy of the current Tetris next block dot column to a const called call, and we will decrement column so that it is moving to the left side. Then we will call our valid move function. Already we have included a condition in valid move to check if the column is greater than less than 0, it will return as false. So if it is not a valid move, that is if the column is not less than 0, then our decremented value will be right. Otherwise we will bring back the original call value to Tetris next block dot column. So now I am pressing the left key and it has moved to the left side. Again I am pressing left and the movement to the left is stopped at 0th column. It is not moving away beyond the 0th column. I could easily move left, and this happens until game over. Now we will go back to our HTML file and replicate for right arrow. So I will copy the same if loop and slightly modify to accommodate the right arrow. As it is known, right arrow is to increment the column position by 1. The right arrow key value is 39. So we are checking if e dot which is equal to 39. We will take a copy of Tetris next block dot column into the column and increment the Tetris next block column. Then we will check if this is a valid move. If not a valid move, we will revoke back the column value to Tetris next block dot column. And then next we will write for down arrow. Down arrow's e dot which is equated to the value of 40. If the down arrow is pressed, we have to speeden up the down movement of the Tetris block. So instead of column, we have to consider Tetris next block dot row and increment the row by 1 position for each down press. And then we will validate the move. If not a valid move, we will reverse back the Tetris next block dot row position to its original value. So we have implemented for 3 key down press. Left arrow column is decremented by 1, right arrow column will be incremented by 1, down arrow row is incremented by 1. Now we will preview this key events once again. Random blocks are coming up. It moved down very fast because I have pressed the down key, and it is moving to the right side. I can move to the left side again I am moving, and down quite made fast, and this Z block is left side down, and again yes I can move to left side. Z block I can move to left side. I can move on to the right left as intended until the game is over. After that any key press will not be detected. So we have completed the detection of key, left press, right key press, and for the down movement there is one more key that we have to do is up arrow. Up arrow is intended to do the functionality of rotating the Tetris block by 90 degrees. So here the up arrow is e dot which is equal to 38. If the key pressed is equal to 38, it is up arrow. As the matrix has to be rotated clockwise by 90 degrees, we will first take the copy of the matrix itself. So I will introduce a const matrix. So I am going to introduce const matrix and take the copy from Tetris next block dot matrix. And before doing the rotation by 90 degree in clockwise, it is easy if our Tetris blocks matrix is a square matrix. Instead of 2 by 3 matrix, if it is 3 by 3, we can use the map method and rotate it easily. So I am going back to the Tetris block and making all the Tetris elements as a square matrix. That is I, J, L, S, Z and T will be 3 by 3. So I am adding an additional row to it. This is the purpose of having a square matrix, so that our rotation by 90 degree we can use the map method. I am not changing for O element because 2 by 2 is already a square matrix. And then again coming back to add event listener, if the up arrow is pressed, we'll take a copy of Tetris next block dot matrix to a const variable called matrix. And then we will introduce a simple algorithm to rotate the matrix by 90 degree in a clockwise direction. For that we will take Tetris next block matrix length -1 and store it in a const n. Then I will also have a variable called result, which will does this reverse followed by the transverse, so that we have the rotation done. For that we will call Tetris next block matrix and use the map function, and which will take the row comma I as a parameter, and then which is transversed to row dot map value comma j, which is reversed to Tetris next block dot matrix with row with the first dimension as n minus j and the second dimension is I. So we have inversed the row and column by using the map element, by changing row to column first and then transversing it. Then next Tetris next block dot matrix should be replaced with the result of 90 degree shift in clockwise direction. Now we will again validate for this new matrix, so that we will call valid move function, and if it is not a valid move, we have to revert back the rotation of matrix by 90 degree. So we will bring back the matrix and store it to Tetris next block dot matrix if it is not a valid move. Otherwise the 90 degree rotation will be kept as such. So by using this simple map method, which can be applied only to the square matrix, we are first transversing and then shifting rows and columns, which will result in 90 degree shift, and then storing it to the Tetris next block dot matrix, and the new one is validated. If it is not a valid move, we will reverse back as we did for other key process. Now coming back to the preview, the Z Tetris element is, I could by pressing up arrow you could watch me changing them. Again for I, it is moving down fast. For the T, again I have rotated it by up arrow. For yes, for L also I could rotate it. For square, although I rotate it, it is not visible. So we have implemented all 4 keys with add event listener, that is left to decrement the row, right arrow to increment the row, to down arrow to move it faster, and up arrow is to rotate the element by 90 degrees.